Hey everyone. Previously we did systems of equations. We solved them using substitution or elimination. Elimination is probably a little bit easier, but we have to know both methods. Well, now we're going to do some word problems. Many problems involve more than one unknown quantity. Although some problems with two unknowns can be solved using just one variable, many times it's easier to use two variables. So we're going to have two unknowns. That means we're going to need two equations. So we're going to set up a system of equations. Here's our procedure. Remember that you could always pause, write notes, catch up. So if I go too fast, just hit pause and catch up with your writing. All right, step one. Determine what you are to find. Assign a variable for each unknown and write down what it represents. If you're looking for the number of apples and the number of bananas, you could use A and B, for A for apples and B for bananas. Traditionally, though, we like to use X and Y. So if there's two unknowns, let X be one of the unknowns, let Y equal the second unknown. Write down any other given information. So it's always good to read the problem, write down some numbers so you don't have to keep rereading it. And then here's the main step. We're going to write a system of equations. Write as many equations as there are unknowns. If there's two unknowns, that means two equations. Solve the system. Use elimination or substitution. We'll do 3 examples today, and we're going to do 2 elimination and 1 substitution. Answer the question and check it. Make sure your answer makes sense. If it comes down to your coffee cost $2, let's say it comes out to be $235, that's probably not right. Maybe you missed a decimal point. Maybe it's $2.35, $2.35. Or let's say you're trying to find the number of adults and you get negative 53. That doesn't make sense, right? You can't have negative 53 people. Or you get 2.7 kids. You can't have 2.7 kids. That's not right. So check your work, make sure it makes sense. All right, here's our first problem. The sum of two numbers is 37, and their difference is negative 3. We're trying to find the two numbers, right? The sum of two numbers is 37, and their difference is negative 3. So two numbers. We have the first number and second number. So x is the first number, and y is the second number. Okay, now our two equations with two unknowns. The sum is 37. Sum means add. Add what? Add the first number and the second number. And the first number is x and the second number is y. So what's our first equation? Yes, x plus y equals 37. Their difference is negative 3. Difference is subtraction. So their difference is negative 3. The difference of x and y is negative 3. X minus y equals negative 3. There, we've done it. We've got our two equations with the two unknowns. This one is set up really well for the elimination method. We could just go ahead and add the two rows together and the y's will cancel. So let's do that. The y's cancel, x and x is 2x. 37 and negative 3 is 34. Now we can divide by 2 on both sides. And that gives you 17. Are we done? No, right? We just got x, we need to find y. So plug that 17 back into either one of the first two equations. I'm going to use the top equation, but you could use either one. So replace x with 17 in the top equation. And now subtract 17 on both sides. That'll give you your answer for y. Now we have our two answers for x and y. We'll just put it together. The two numbers are 17 and 20. Does it sound right? Does it make sense? Is there some 37? Yep. Is there difference -3? Yep. All right, we're done with that first example. Let's go on to our next example. Laura and Tony are planning to move and need to buy some cardboard boxes. At Smart & Final, they could either buy 10 small and 12 medium for $42, or 5 small and 10 medium for $29. Find the cost of each box. All right, what are we trying to find? The cost of each box. Right? That's our x and y. We have two boxes. We have small ones and medium ones. So x is the cost of a small box. Y is the cost of a medium box. Now we need our two equations, right? 10 small and 12 medium for $42. So it's 10 times how much a small box costs, plus 12 times however much a medium box costs. That'll give us $42. That's our first equation, 10x plus 12y equals 42. Can you figure out what the second equation is going to be? It says 5 small and 10 medium cost $29. Yeah, that's it. 5x plus 10y equals 29. We've done it. We've got our two equations with two unknowns. Again, we're going to use the elimination method. You could either get rid of the x or the y. I think that let's get rid of the x. We can just multiply the bottom row by -2. That'll get us the top row to have a +10 and the bottom row to have a -10. And when we add them, they'll cancel. If we want to get rid of the y's, that's a little bit more work. We've got to make them both into a 60. One of them positive, one negative. So let's stay with the x. Multiply the bottom row by -2. Okay, the top row is going to stay the same. So the bottom row is going to be -10x minus 20y equals -58. Add those two rows together. The x's cancel. -8y equals -16. Divide both sides by -8. Y equals 2. Now that's just y. We still got to find x. You got to take that y and plug it into one of the first two equations, any two, or your choice. I'm going to use the bottom row. So replace the y with 2 and leave the x alone. So 5x plus 10 times 2 equals 29. Multiply the 10 times 2, which is 20. And then subtract 20 on both sides. That'll give you 5x equals 9. Now divide by 5, 1.8. So we got our two numbers. Make sure you put it in the form of currency. 1.8 is $1.80, right? You don't want to say 1.8. Maybe somebody gets confused and thinks it's $1.08. And 2, somebody might think it's 2 pennies, right? So it's 2.00 for y and 1.8 for x. X is the cost of a small box, so that's our small boxes, which is $1.80, and a medium box is $2. All right, we'll do one more example. On the next example, we'll use substitution just to do one different. All right, go ahead and read it. Tickets to a play at Cucamonga Junior High cost $2.50 for general admission and $2 with a student identification. So students are $2, non-students are $2.50. 92 people paid to see a performance, and $203 was collected. How many of each type of admission were sold? How many of each type of admission? So there's two types, right? There's general admission, that's non-students, and $2, that's the students. So that's our X and Y. X is not the cost, because we know how much it costs, right? It's how many people. So X is the number of general admission tickets sold, and Y is the number of student tickets sold. Yeah, we don't want to put cost because we already have the cost. We're trying to find out how many of these tickets were sold. And each ticket represents a person, right? If Y is the number of student tickets sold, that means Y is also the number of students that attended, that paid their $2. All right. So what's our first equation? There's 92 people that paid. 92 people paid. That means there's 92 people from the general admission and the students that attended. So that's our first equation. X plus Y equals 92. That's the number of students plus the number of non-students equals 92. That's kind of our people equation. People plus people have to equal people. Our second equation has to do with the money. $203 was collected. $2.50 for general admission and $2 for students. $2 for students. So our second equation, 250 times however many people paid general admission plus $2 times the number of people that paid the student price. 250x plus 2y equals 203. That's our money equation. Money plus money has to equal, money. All right, let's use the substitution method. Let's take the top row, and you can either get x or y by itself. I think we'll get x by itself. So take the top row and subtract y on both sides. That gives you x equals 92 minus y. And then take that 92 minus y and replace it with x in the other equation. So 250 times 92 minus y, make sure you put it in parentheses because you're going to have to distribute, plus 2y equals 203. Remember, you can always pause and work it out on your own. Distribute the 250. So 250 times 92, and then 250 times negative y. So that's 230 minus 250y plus 2y equals 203. Add your like terms, and then subtract 230 on both sides. All right, so when you subtract 230 on both sides, you get a negative 27 on the right. And negative 0.5 comes from the negative 2.5 plus 2. The signs are different, so subtract and then keep the sign of the larger. Now divide by negative 0.5 on both sides, and that'll give you 54. That's a good number, right? 54 represents the number of student tickets sold. They sold 54 student tickets. That's good. Let's say it came out to be a negative number. Could you have a negative number of student tickets sold? No, that wouldn't make any sense. We got positive 54. That looks good. Could you get a decimal? No, you could get like 2.3 tickets sold. That doesn't make any sense. Nobody's going to buy 0.3 tickets. So it needs to be a whole number. 54 looks good. Take that 54 and replace it back into either equation. I'm going to use the top one. I think that's easier. Or actually, the one that says x equals 92 minus y, because x is already by itself. So put that 54 in place of y into the x equals 92 minus y, and then subtract, gives us 38. So 38 general admission tickets sold and 54 student tickets sold. That adds up to be 92. That's good. And if you multiply 38 times 2.5 and 54 times 2 and then add those together, you're going to get $203. So our answer looks good. All right, I'll see you here for the next video.